Understand modern data integration with Airbyte in just 15 minutes. Learn how it is changing the game from traditional ETL to streamlined ELT process. Hello everyone, in this video I'm going to cover how ELT is different from ETL, what is Airbyte, its features and core concepts, and Airbyte demonstration. First difference is in the order and method of data processing. In traditional ETL, it extracts data from source first, transforms data, load into data warehouse. Whereas in ELT, it extracts like the traditional ETL, and then it loads data into data warehouse. Afterwards, it does the transformation. Performance. Traditional ETL is generally slower with the larger data sets due to the transformation step before loading. Whereas in ELT, it is generally faster even with the larger data sets as it leverages the processing power of modern data warehouse for the transformation step. Extraction and load, it is anyway simple. It's the transformation that usually takes the time. So in ELT, you can do the transformation on the data warehouse itself. Flexibility. Less flexible as data is transformed beforehand, retransforming requires reprocessing. Suppose once ETL process is done, there is a problem with the transformation. If you make a change, you need to run the entire pipeline again. Whereas in the ELT, you don't need to extract load again. You just update your transformation, you just rerun the transformation. Use cases. Suited for small data sets or when pre-processing is essential before loading. Whereas ELT, it is ideal for large volumes of data and when leveraging cloud-based data warehouses. Technology relies on separate transformation tools and computing cluster outside the data warehouse. Whereas ELT depend on the capabilities of the data warehouse technology. What is Airbyte? Airbyte is a leading open source ELT platform that replicates data from applications, APIs, and database to data warehouses, data lakes, and other destinations. Airbyte offers over 350 plus out-of-the-box connectors, and you can also custom build through a low-code connector builder. Now let's get into Airbyte core concepts and some of its terminology. Airbyte enables you to build data pipelines and replicate data from a source to a destination. You can configure how frequently the data is synced, what data is replicated, and how the data is written to in the destination. A source. A source is an API, file, database, or a data warehouse that you want to ingest data from. A destination. A destination is a data warehouse, data lake, database, or an analytics tool where you want to load your ingested data. A connector. A connector is an Airbyte component which pulls data from a source or pushes data to a destination. A connection. The connection is an automated data pipeline that replicates data from source to a destination. Setting up a connection enables configuration of updating frequency, destination namespace, how should the data be replicated, schema propagation, if there is any changes to schema, catalog selection, all these configured under connection. A stream. A stream is a group of related records. For example, a table in relational database is a stream. A collection in NoSQL database is a stream. A resource or API endpoint for a REST API is a stream. A namespace. A namespace defines where the data will be written to your destination. In relational database system, this is typically known as schema. There are two options to work with Airbyte. First option, it is being an open source platform. We can set up our own environment. Second option, Airbyte provides a cloud environment. We can sign up and use it, pay as we use. For this demonstration, we are going to use a cloud option. Okay, when it comes to the function setting, here we are going to connect with two source applications with a data warehouse. Source one is a loan processing management system. Second, CRM. We are going to connect these two source applications to a data warehouse. Okay, so when we club loan processing system with a CRM, there are so many insights a business can get out of it. For example, we can get customer segmentation and targeting, loan approval rates, risk assessment and accuracy, loan portfolio performance, default predictions. I'll start setting sources first. What is our source one? It is loan processing management system. It is storing data in a Postgres database. We'll select the connector, built-in connector. So we need to now configure it with Postgres database hostname, database name, loan management. We have a default Postgres user. Okay. And then we are going to use the second update method, detect changes with min system column. This is suggestible when the table size is max up to 500 GB. If it is more than 500 GB, then that's when it is suggested to go with write ahead log. Setup source. Okay, all test passed. It's very good. So now set up the second source. Second source application is CRM. It stores data in MongoDB. Let's find out MongoDB connector. Okay, there it is. So it is hosted on MongoDB at last. Connection string, database name, user, password, setup source. Okay, so we successfully connected to MongoDB as well. Now let's establish a connection with Redshift. So Redshift is our data warehouse. Okay. Connection host, username, password, database, main database. Okay, so this is important here. Uploading method, AWS S3 staging and standard. So generally suggested that use the first option. So what it does when it is uploading data to the Redshift, so first it will stage data to S3 bucket, and then from there it uses the copy command to copy data from S3 to Redshift. Okay, so I already set up S3 bucket. I need to give the bucket name. Change US is to access key, secret access key. Set up destination. Okay, the connection successful. Now we need to set up two connections between sources and destination. So one connection from Postgres to Redshift, second connection from MongoDB to Redshift. Before setting up these connections, let's quickly go to Redshift data warehouse and see if there's any existing data. Similarly, maybe we can also go to Postgres and see what kind of data is available there. First, let's go to Redshift. Okay, so this is the cluster that's launched. We go to the cluster. I want to query the data. Okay, so in this cluster, we have Dev database, public schema, and you see that there is no data at all here. And let's connect to Postgres and see. Okay, so here we have three tables: loan applications, loan payments, loans. Okay, so in loan applications, we have a couple of sample rows. Okay, let's do the connection between Postgres and Redshift. Create your connection. Okay, Postgres, existing destination Redshift. Data residency. So this is like if you have to follow certain GDPR regulations, you can select where do you process the data. So I select United States. This is the scheduling configuration. So you can set up how frequently you want to sync up the source and destination. So for now, just keeping it to 24 hours. Okay, destination namespace. If you want, you can check it out. Okay, so I'm saying that like no, you just use the same public namespace, and then this is the propagate schema changes, propagate field changes only. I'm leaving it as a default. So if there's any changes to field type, if fields are altered, the changes will also reflect in the data warehouse. Okay, so here you can see so that all the three tables. So each table is considered as a stream. Okay, first let's sync up loan applications, set up the connection. Okay, connection is done and first sync happened. Let's check the Redshift if the data has been copied over to Redshift. Okay, just refresh it. Okay, database, okay, public schema. Oh, there you see, there are three. Okay, so these are the supporting tables that are created by Airbyte, but the main table is loan application. Let's check. Okay, so we got two rows copied over, customer ID 104, customer ID 105, and you can see that Airbyte added a unique key to each row and then a couple of other additional columns. Okay, now let's set up the second connection between MongoDB and Redshift. New connection, selecting existing source, MongoDB, destination Redshift. So it's now fetching the schema of data sources. Okay, data residency states. We leave the scheduling as is. Destination namespace public we leave as is. And so this is a customer sees the collection that we are going to sync up with the Redshift. Set up connection. Okay, connection has been successfully established. Let's go to Redshift and check if we got the data synced up. Refresh it. Okay, so you see the table number of tables count increased. Okay, there you go, customers. Let's query customers. Okay, there you see all the three documents from MongoDB copied over to Redshift. So that means our integration is good. So now let's get back to our source one application loan processing system and make some updates there and see that how those updates are going to flow to data warehouse. Okay, I'm going to insert one row and I'll update an existing row. And I'm inserting one new customer. Made an update to existing customer. Now let's run Airbyte and then see how the sync is working. Go to the Postgres connection. Okay, sync now. Okay, incremental sync is successful. Let's check the data in Redshift. Query the loan application table. Okay, you see three rows. Customer ID 106 got inserted and 104 status should be changed to approved. Okay, there you go. As you can see, setting up Airbyte is very simple, easy to sync and easy to maintain. As we have seen, Airbyte's powering integrating diverse fintech data sources like Postgres, MongoDB into Amazon Redshift is not just impressive, it is transformative. This demonstration highlights how Airbyte simplifies the complex task of consolidating customer and loan processing data by enabling a seamless flow of information into a centralized data warehouse. This capability is crucial for any fintech business looking to leverage data for informed decision making, enhanced customer experiences, and operational efficiency. Remember, what we cover now is just tip of the iceberg. Airbyte's flexibility and wide range of connectors open up a world of possibilities for data integration across various industries and use cases. So if you are diving into the world of data integration, or if you are a fintech professional looking to enhance your data infrastructure, I encourage you to explore Airbyte further. The open source community around it is vibrant and constantly evolving, offering new features and improvements. I hope this video is helpful to you. Have questions or want to see more about specific feature? Drop a comment below. I would love to hear your thoughts and suggestions for future videos. This is Sagar signing off. Keep integrating and stay data savvy.